The sun, a blazing ball of fire, a source of life and energy. For centuries we've gazed upon it with awe. We've studied its light, its heat, its power. But what if I told you the sun isn't silent? What if I told you it has a voice? A voice that's both mesmerizing and unsettling. NASA, in its quest to unravel the mysteries of the cosmos, has captured the eerie sounds of the sun. These sounds, far from a gentle hum, are a symphony of hisses, crackles, and deep, resonant vibrations. They are a testament to the immense power and constant activity of our nearest star. Imagine standing on the edge of a vast, echoing chamber. The air is thick with anticipation. And then you hear it. A low, rumbling sound. It rises and falls like the breath of a sleeping giant. This, my friends, is the sound of the sun. It's a sound that speaks of the immense forces at play in our universe. It's a sound that reminds us of the sheer scale and wonder of the cosmos. But how can the sun make noise? We all know that sound can't travel through the vacuum of space, right? Well, the answer lies in the fascinating world of data sonification. NASA scientists, using specialized instruments, have been able to convert the sun's electromagnetic waves into sound waves that we can hear. It's like translating a secret language, one that allows us to experience the sun in a whole new way. These sounds are not just fascinating, they're crucial to our understanding of the sun. They provide valuable insights into the sun's internal structure, its magnetic fields, and its violent eruptions. By studying these sounds, scientists can learn more about how the sun works and how its activity affects us here on Earth. So buckle up as we embark on a journey to explore the creepy, captivating sounds of the sun. For years we've been led to believe that space is silent, a vast, empty void where no sound can exist. This misconception stems from the simple fact that sound waves need a medium to travel, like air or water. And space, as we know, is a vacuum. But here's the catch. Space isn't completely empty. It's teeming with electromagnetic waves, a form of energy that travels through the vacuum of space at the speed of light. Think of it like this. Imagine a calm lake. On the surface it seems still and serene, but beneath the surface there's a whole world of currents and movements. Similarly, space may appear silent, but it's actually buzzing with activity, with electromagnetic waves constantly rippling through it. These waves come in many forms, from radio waves and microwaves to X-rays and gamma rays. And each type of wave carries information about the objects and events that created them. Now, while we can't hear these electromagnetic waves directly, scientists have found a way to unlock their hidden symphony. This is where data sonification comes in. It's a process that converts data, in this case the patterns and fluctuations of electromagnetic waves, into sound. Imagine taking a beautiful painting and translating its colors and shapes into music. That's essentially what data sonification does for space sounds. By converting these invisible waves into audible sounds, scientists can hear the universe in a whole new way. They can listen to the whispers of distant stars, the roars of black holes, and yes, even the eerie hum of our own sun. It's like having a new sense, one that allows us to perceive the cosmos in all its glory. So the next time someone tells you space is silent, you can confidently tell them, think again. Space is alive with sound, waiting to be heard. How exactly do we capture the sounds of a celestial object millions of kilometers away? The answer lies in a fleet of sophisticated spacecraft and instruments designed to study the sun. One such mission is the Solar and Heliospheric Observatory, or SOHO, a joint project between NASA and the European Space Agency. Launched in 1995, SOHO has been keeping a watchful eye on the sun, observing its every move. SOHO is equipped with an instrument called the Michelson Doppler Imager, or MDI. This instrument measures the oscillations of the sun's surface, which are essentially ripples of energy traveling through the sun's atmosphere. These cause the sun's surface to rise and fall, much like the waves on an ocean. The MDI records these movements over time, creating a detailed map of the sun's vibrations. Another key player in capturing the sun's sounds is the Solar Dynamics Observatory, or SDO, launched in 2010. SDO is like a high-definition camera in space, constantly capturing stunning images of the sun in various wavelengths. It observes the sun's magnetic field, its atmosphere, and its explosive events like solar flares and coronal mass ejections. The data from SOHO and SDO, along with other solar observatories, is then beamed back to Earth, where scientists use sophisticated algorithms to process it. This is where the magic of data sonification happens. By converting the sun's oscillations and other activity patterns into sound waves, scientists can listen to the sun's symphony. And let me tell you, it's a symphony unlike anything you've ever heard. Imagine a deep, resonant hum, punctuated by pops, crackles, and hisses. It's a sound that's both mesmerizing and unsettling, a constant reminder of the immense power of our nearest star. In the next section, we'll delve deeper into the science behind these sounds and explore what they reveal about the sun's inner workings. So we know that scientists can capture the sounds of the sun by converting its electromagnetic waves into sound waves. But what exactly causes these sounds? What are we actually hearing when we listen to the sun's eerie symphony? The answer lies in the sun's dynamic and turbulent nature. Imagine a pot of boiling water. As the water heats up, it bubbles and churns, creating a symphony of pops and hisses. Now imagine this on a much grander scale. The sun, a giant ball of hot ionized gas called plasma, is in a constant state of convection. Hot plasma from the sun's core rises to the surface, cools down, and then sinks back down, creating a continuous churning motion. This churning motion generates waves of energy that travel throughout the sun's interior and across its surface. These waves, known as pressure waves or acoustic waves, are similar to sound waves here on Earth. As these waves propagate through the sun, they interact with its magnetic fields and oscillations. Think of it like plucking a guitar string. The string vibrates, creating sound waves that travel through the air to our ears. Similarly, the sun's internal movements and magnetic fields create a symphony of vibrations that travel through space as electromagnetic waves. By capturing and converting these waves into sound, scientists can listen to the sun's internal music, a music that reveals a wealth of information about our star. Section 5. Unraveling the sun's secrets, the importance of solar sounds. The eerie sounds of the sun are more than just a cosmic curiosity. They are a valuable tool for scientists studying our nearest star. By listening to the sun's symphony, scientists can gain insights into its internal structure, its magnetic fields, and its violent outbursts. One of the key areas where solar sounds are proving invaluable is in the study of the sun's interior. Just like geologists use seismic waves from earthquakes to study Earth's interior, physicists use the sun's acoustic waves to probe its hidden depths. By analyzing the way these waves travel through the sun, scientists can create detailed maps of its internal structure, revealing information about its temperature, density, and composition. Solar sounds are also helping scientists understand the sun's magnetic field, a complex and ever-changing force that plays a crucial role in solar activity. The sun's magnetic field lines are like invisible highways, guiding the flow of charged particles. When these field lines get twisted and tangled, they can release enormous amounts of energy in the form of solar flares and coronal mass ejections. These eruptions can have significant impacts on Earth, disrupting satellites, power grids, and communication systems. By studying the patterns and variations in the sun's sounds, scientists can track the movements of its magnetic field lines. This information helps them understand how solar flares and coronal mass ejections are triggered, paving the way for better space weather forecasting. In essence, listening to the sun's sounds helps us predict and prepare for its potentially disruptive outbursts. So why do these sounds evoke fear? Well, it's all about our primal instincts. You see, humans are hardwired to respond to certain frequencies and patterns that signal danger. When we hear these unsettling sounds from space, our brains can't help but react with a sense of unease. It's a survival mechanism, really. These sounds trigger our fight or flight response, making us hyper-aware of potential threats. Fascinating, isn't it? But you know, the universe has even more eerie sounds to offer. From the haunting hums of distant planets to the eerie whistling of cosmic winds, space is full of mysterious noises. Each sound tells a unique story about the celestial bodies that produce them. It's like the universe has its own language, speaking to us through these strange and captivating sounds. Yet, amidst all these eerie sounds, there's an undeniable beauty in cosmic music. The rhythmic pulses of pulsars, the harmonious vibrations of interstellar gas clouds, and the melodic waves of gravitational ripples create a symphony that transcends human comprehension. It's a reminder of the vastness and complexity of the cosmos, and how, even in its most mysterious moments, there's a profound beauty to be found. So, as we conclude our journey through the sounds of space, let's take a moment to appreciate the wonders of our universe. These sounds, though sometimes unsettling, offer us a glimpse into the unknown. They invite us to explore, to question, and to marvel at the infinite possibilities that lie beyond our world. Until next time, keep looking up, and keep listening to the music of the cosmos.